Alright, welcome to part 2 of the worded problems. We're going to go straight into a question. So this question is saying the heights and weights of a student in a class of 6 are described by the following table. So these are weights and heights of 6 students. Right? If part A is saying plot the coordinates and sketch the graph of height against W weight. Alright, height and weight you got to sketch. So what does it mean by coordinates? Pretty much, right? Each of these is a coordinate. So weight is kind of like your x coordinate, and height is kind of like your y coordinate. So for example, this column would be 62 and 165 in coordinate form. Likewise, this would be 64 and 169. All right, so these are coordinates. So why don't you guys pause the video and try plot all of these coordinates. All right, so I've already done that. I've already done that beforehand. So you notice I made a proper axis and everything, and you'll notice if you plot all of them, they should kind of make a nice straight line. So to sketch the graph, we just need to connect all those lines roughly and make that, just about there. Okay. Again, I'm stopping at this point, guys. Why? Because can I have a weight of -10? Well, that doesn't make sense. You probably just float away from Earth if you have a negative weight. So probably not, right? So that's why I'm just stopping. I'm not going any further to the left because I cannot have a negative weight. All right. So this would represent my h. What's on the vertical axis? I said h is our y variables. So on the vertical axis is h, height. Height is measured in centimeters in this question. And what's on the horizontal axis? Horizontal axis is weight in kilograms. Okay, so that's our graph. Let's do part B. Part B is saying find the rule for height, c centimeter, height h, which is h centimeters in terms of weight, w kilograms. So h and w, pretty much just find the rule of this line. Okay, so in order to do that, remember, we just need to get two coordinates. I'm just going to take both these coordinates I found earlier. And then we just need to find the equation between two coordinates, which we've already done plenty of, right, guys? We've done it in the previous chapters. So tell me, guys, what do you do first? Well, remember, equation of any line is equal to y is equal to mx plus c. Step number one was to find m. How do you find m? Well, if you have two coordinates, the way you find m is the exact same thing. x1, y1, so exact same thing as what we did before. And x2 and y2. And the equation, remember, is m is equal to y2 minus y1 over x2 minus x1, and just find the gradient. All right, so now if you think you know, do the question. Find me the equation. So I'll do it there. M is equal to y2 is 169 minus y1 is 165 over x2 is 64 minus x1 is 62. So it's pretty much 4 over 2. See, it's a nice easy number. M is equal to 2. All right, so then we substitute this into our main equation. Y is equal to 2x plus c. Then how do you find the value of c? We just sub any of these coordinates in. I'm going to pick the first one because it's easier. So I'm going to sub 62 and 165. So remember, this is our x value, this is our y value. We sub it in. 165 is equal to 2 multiplied by 62 plus c. 165 is equal to, that's 124 plus c. Then 165 minus 124 is c. So c is equal to, what's that? So 41 is our c value. So y is equal to 2x plus 41. And if you notice, right, from our graph, right, what's the y-intercept we got from this? Well, the y-intercept is 41, right? You'll notice it's very close. I kind of messed up the scale, but it's very, very close to 41, right? I got on 40, but, there's a bit of error when you're sketching because sketching is not entirely accurate, right? Part C is saying find the rule to find the values of h if the weight is 80 kilograms. So find the height pretty much if another person in this class weighs 80 kilograms. So what's our rule? Rule? It's not y and x, actually. I made a mistake on purpose. Well, on purpose. I just realized, right? We don't have y and x in this question. What do we have? We have h and w, right? So this equation cannot have y and x in it, right? It must have, what was our vertical variable or y variable? It was h. So h is equal to 2. And what was the x variable? X variable was w, weight, plus 41. So in fact, guys, if you write this equation, you would be incorrect, wrong. Because there's no y and x in this question. There's only height and weight, which are the only two variables you're allowed to use for your answer. Okay? So this is our equation. I'm glad I made that mistake, so now you guys know. Alright, so our equation, like I said, is h is equal to 2w plus 41. Okay, it's saying find the height if someone weighs 80 kilograms. So w is equal to 80. So it's simple to find. It's kind of like saying x is equal to 80. Just saying. So all you have to do is sub it into this formula instead of W. So height is equal to 2 times 80 plus 41. So height is equal to 160 plus 41. Height is equal to 201 centimeters. Make sure you do units, right? Just find height. Height means there's height units, right? You can't just do 201 like that. What, 201 bananas, 201 apples, oranges? No, you have to put units, 201 centimeters. All right, that's part A. Part B is saying find the weight if the height is equal to 175. So I think you can guess. We sub 175 instead of W, we sub it into H and solve for W. So let's do it. So H is equal to 175. So part B, 175 is equal to 2W plus 41 and solve for W. So we have to do 175 minus 41 is 2W. That's going to be 134. I think I got that right. Yeah, 134 is 2W. And then you need to divide by 134 by 2. So W is going to be equal to, see if you can do it quicker than me, 67 kilograms. I'm too fast for you. I don't know. I'm assuming I'll beat you. I don't know. Okay, so pretty much if height is equal to 175, weight is 67. So what are our coordinates, guys? For part A, our coordinate, our weight was 80, so x coordinate is 80, and our height was 201. So, and then this coordinate, weight is 67, and the height we subbed in was 175. So I just want to show you graphically really quickly. So pretty much what was our coordinates? It was 60, I forgot already, 67 and 175, 67, 175. So graphically, 67 would roughly be over here. So if you kind of map it up to our equation of the straight line, and then we try to find the y, sort of the y coordinate, you see it's 170, it's actually bang on, 175, right? So that's it. I'm just showing you graphically how it all works. All right, I think that's this question done. Okay, yeah, question number 4. Pause the video and have a go. All right, let's do it together. Again, I'm going to highlight all the important information on this. So Kevin Hart is doing, I love Kevin Hart, great comedian by the way. Watch his Netflix specials. Not now, I've finished this video and then watch his Netflix special. It's very funny. All right, Kevin Hart is doing a show in Melbourne and he decides to go on a run to calm his mind. He starts his run at a point, so he's going on a run and he starts at a point 5 kilometers away from his house. So he's going, okay. And then he started the running at a speed of 8 kilometers per hour towards Marvel Arena. So that's his destination, which is total 15 kilometers from his house. He stops running as soon as he reaches the arena. So he's going to his destination. All right, let's do it. So firstly, we have his house. Let's say H for house. And then he's starting 5 kilometers away from his house. So over there. Let's say this is his starting point. And this is 5 kilometers. Okay, sure. And he starts running his speed. So his speed, we'll write down here, is equal to 8 kilometers per hour. Towards Marvel Arena, which is 15 kilometers from his house. So I guess from here to here is Marvel Arena. So the M for Marvel Arena, which is total 15 kilometers. Okay, so from his house, it's 15 kilometers. 15 kilometers. So then, guys, how far is it from his starting point? So in other words, what's this distance? Well, it's 15 minus 5. It's 10 kilometers. So this part is 10 kilometers. Okay, sure. All right, I think that's all the information represented. So now we start doing the question, right? So I've drawn a diagram using all the information I had. And now we can start doing the questions, part A. So part A is saying, find this equation of his distance from his house in terms of time, t hours. Okay, sure. Let's sub some values in, okay? So if t is equal to 0, right? So if t is equal to 0, that means he's just started. How far away is he from his house? Well, his distance from his house is 5 kilometers. Sure. If t is equal to 1, how far away is he? So 1 hour. He's been running for 1 hour. Well, distance would be, if he's running 8 kilometers every hour. So the way you can kind of think of this, he's traveling 8 kilometers every hour. So, right? So if he's 1 hour, if he's been running for 1 hour, he's traveled 8 kilometers. So it'll be 5 plus 8. So it's going to be 13 kilometers. So can you guys come up with the rule for D1 now? Well, let's think about it. D1 is going to be the initial 5. So the 5 kilometers is the starting point. Plus, he's running every t hours, he's running 8 kilometers. So it's pretty much this distance from his house in terms of time. Okay, so again, 5 is the starting point and he's running 8 kilometers every hour. It's similar to how we did back in the previous video. Okay. Next, part B, it's asking, find the equation of distance from Marvel Arena. This time it's asking for Marvel Arena in terms of t hours. Again, let's sub some values in for Marvel Arena, so D2. So if time is equal to 0, so at the very start, how far away is he from a Marvel Arena? Well, he's D1 would be, D2, sorry, would be 10 kilometers, right? Because at the very start, he's a total of 10 kilometers away. Yep, he's 10 kilometers away. So if t is equal to 1, then he's traveled how long? In 1 hour, he travels 8 kilometers. So he's gone closer, right? So he's gone 8 kilometers closer. So the answer is 2. He's 2 kilometers away. So pretty much in 1 hour, he travels 8 kilometers. So he'd be 2 kilometers away. That's the kind of logic I'm going for. All right. So I think we have enough information. D2, well, he's starting off 10 kilometers away and he's getting closer, right? So you have to subtract by his speed, 8t, because every hour he travels 8 kilometers. So this kind of his distance. So you're getting closer. All right, so we've got 2 equations. Hope that makes sense. But if it doesn't, I'm gonna skip part C and we're gonna sketch both of these graphs just to kind of give you an idea of what's going on. So it says sketch both graphs of D1 and D2. Okay, here. So D1 was 5 plus 8t and D2 was 10 minus 8t. Okay, I'm going to rewrite this with y and x just to make it easier to sketch. Y is equal to 5 plus 8x. You don't have to do this. I'm just doing it just in case. It does make it a bit easier, I find, for my students. So y is equal to 10 minus 8x. So we're going to sketch both of these graphs. So we're going to do the same thing. Find the x-intercept, y-intercept, and sketch. All right. So y, for the first one, y is equal to 5 plus 8x. We find the x-intercept. Let's do that first. Make y 0, so 0 is equal to 5 plus 8x. Negative 5 is equal to 8x. X is equal to negative 5 over 8. Negative 5 over 8, let's just say it's over here. And then we have to find the y-intercept. Y-intercept is just 5 because he's subbing x equals 0. So I'll just do that quickly. Let's say y-intercept is here. And then obviously sketch, but connect the dots. Connect both those lines. I missed that dot, so I'm just going to change it. All right, so that's the first graph, D1. All right, next graph was 10 minus 8t. D is equal to 10 minus 8t. So I'm going to use d and t instead of y and x just to show you what it's like. So remember, to find the t-intercept, kind of t-intercept is the x-intercept, you make d is equal to 0. So it's the same thing, same logic. 0 is equal to 10 minus 8t. Take 10 to the other side. Negative 10 is equal to negative 8t. T is equal to, you can make it positive, 10 over 8. So time is going to be 5 over 4 hours. Okay, and likewise, what's our d-intercept? So it's like a y-intercept. You make t 0. So d is equal to 10 minus 8 times 0. So distance is equal to 10. Okay, that makes sense. He's traveled 10 kilometers. All right, so the coordinate of this is 0, 10. Coordinate of the t-intercept is 5 on 4 and 0. All right, let's plot both of them. Kind of would be 5 on 4 would be roughly, I would say, over here. Let's say a bit closer. Let's say, hey, we are fine. Okay, 5, it will actually be further away. Sorry, because if this is negative 5 on 4, it kind of be this double of that distance to the right. And we have 0 and 10. So that first one was 0 and... Oh yeah, so 0 and 10. So it has to go to this coordinate. All right. So this is, because remember, this is 0 and 10 we got from the first graph. So pretty much, hang on, am I stumbling a bit? No. That should be fine. No, that's 0 and 5. Yeah, I thought so, guys. I made a mistake. This first one is 0 and 5. Right, this is 0 and 5. So 0 and 10 would be double that. So 1, 2, 3, 4, 5 would be here roughly. And then you can sketch the graph, connect the dots. Okay, there. 0 and 10. Okay, again, guys, remember what I said. The vertical axis represents D, which is distance. One is distance from his house, the other is distance from Marvel Arena. Remember, both there's 2 distances. So this is D kilometers and T hours. Okay, so remember, distance cannot be negative, so no y values can be negative. So you get rid of everything below the x-axis, everything below the horizontal axis, I should say. Okay, and likewise, I cannot have a negative time, right? I cannot have anything less. It doesn't make sense. So I'm going to get rid of everything to the left. So all you're left with is, pretty much, guys, the shortcut is quadrant 1, right? So just keep everything in quadrant 1. Everything that's not quadrant 1, just get rid of it. And boop, that's it. Okay, So this is kind of what represents your graph. Now, there's an interesting point I have to make, right? Does he just keep traveling forever? Obviously, there's an endpoint. Oops. There's an endpoint over here for the second graph. That's when he stops. So he stops at, what was the x-intercept? It was 5 on 4 and 0. So that's where he stops, right? But over here, does he just keep running forever? Right? Are we just saying he keeps running forever? No, there has to be some sort of endpoint, right? So when does he stop? Well, he stops pretty much when he gets to the destination, when he gets to Marvel Arena, right? When does he get to Marvel Arena? At this point, when time is equal to 5 on 4. So pretty much you can just kind of map it, like that, and kind of guesstimate and do like that. But I find that's a bit dodgy. Doesn't really make sense. So what we're going to use is this equation instead, the first one. So D1 is equal to 5 plus 8t, right? So when does he get to Marvel Arena? Well, we know the Marvel Arena, if you go back to the diagram, so this is starting point. The distance from his house should be what? The distance from his house should be 15, right? When he gets to Marvel Arena, because it's 15 kilometers. So what we're going to do, if you do properly, is we're going to make distance. Remember, the D1 was his distance from his house. He should be 15 kilometers when he gets to Marvel Arena, is 5 plus 8t, and solve from that. So you get 10 is equal to 8t, and t is equal to 10 over 8, which is just 5 over 4. So it's kind of the proper way of doing it. So like I said, it's just 5 over 4. So you kind of map it. So it would be 5 on 4 over here. And you have to say kind of the end point over here is 5 on 4. And what's his distance from his house? It's 15 kilometers. Okay. So remember, he doesn't keep running forever. That means you have to stop. Okay. So that would be kind of the final answer of this question. Okay. So next, we need to do a part C because we skipped it. Okay, how long does it take for him to reach Marvel Arena? Well, we already kind of just did that, right? Because we just did it literally. We said, well, distance is he travels 15 kilometers from his house. That's his distance when he reaches Marvel Arena, and that is 5 on 4 hours. So we can say answer to part C is 5 over 4 hours. So you can convert that to minutes if you want. It's just going to be 1 hour and 15 minutes. Okay, convert that quickly because 1 1/4. All right, so I hope you understand that one. Remember, the biggest takeaway from this lesson and the previous lesson is kind of getting used to not just having y and having x on your axes anymore when you're sketching. You need to deal with new variables like volume, distance, time, speed, even speed graphs you can sketch, okay? So that's kind of the big takeaway from this lesson. All right, that's it for this lesson. I'll see you soon.